Does anyone have questions till now? What we have done till now? Anyone with questions? No questions? Nice. Well, if you have questions, let me know. First thing first, let's gonna start organizing the grasshopper code we have done till today. My definition should look a bit more messy than yours because I have here, I need to test a lot of things before every class. So I have multiple definitions. But what we have done is from these big yellow panels behind is the code that we have developed till today. For today, we have to develop something similar to this. I'm going to implement some changes from previous years, but this is the code that we are going to develop, okay? So let's gonna have a look together what we have done till now to start labeling things and organize our definitions first, okay? So first day was super simple. Class number one, we did the building just a test. We did a cube, I remember, okay, with a rectangle. I call it building test. Class number two, we did the surrounding buildings, the neighborhood, right? We built the neighborhood that is here, okay, and then we bake it. This was class number two. Class number three, this is class number three, sorry. We built our, what I call the source geometry, okay? The source geometry, the base geometry that we are going to use to generate our buildings. This was generated with some curves directly. If you don't want to generate it with curves, you can do it like we did the other day with, like day one, with rectangles. You just need to provide 3 points, okay? And you will have buildings like this, okay? You can provide also a list of domains, and then every building will be different, okay? I think that the process is very simple, but we did it with 3 curves, trying to make it easier for you, okay? Then we did the gradient building this day. Gradient building was just to show you a bit how to do the isotrim of a surface, how to divide the surface into different pieces, and then we did the extrusion based on our attractor point, right? It was like this. Okay. This was class number 3. Okay. Class number 4, we did the filtering in our gradient building. We create the hole inside, and we also open the path. Okay. This I call it gradient building path opening, gradient building center hole, for example. Okay. Just for us to know, to label a little bit the code that we are developing, okay? And then very important, because with this we are going to continue, we did the first modification to our source building. For the final submission, guys, you are not going to use, unfortunately, you're not going to use the building of big. You're not going to use this building, okay? Because the development of this building is kind of short, okay? You're going to use the source building that we did in class number 3 and the modification of the rotation that we did in class number 4. Because what we did was get the source building and then apply this rotation, depending on an attractor point also. Okay, so if I move my attractor point, my buildings were facing this point, okay? Good. Once we have this rotated building in class number 5, okay, we apply 2 modifications more. One was the scale non-uniform was called modification 1.2, scale non-uniform, and modification 1.3, the twist. Okay, we did the twisting of our building. And in my case, I was twisting too much and I need to reduce the twist, but it's fine. Okay. Good. Okay, this was class number 5. And last class was class number 6, which the last day we did the third modification. Modification 1.4, shear angle. The shear angle modification, we did it with the original buildings, with the buildings unmodified, okay, with the source geometry. I think, let me see if it's possible to do it with the modified geometry also, with the one that we are rotating. Maybe it's possible. I'm not sure. I don't think so. Let's gonna try. Yeah, it's working also. So it's working, no problem. You can do it with both of them, okay? With the rotation or with the uh, source geometry, let's say. You can use both, okay? But additionally to this, what we did was the contours in this class, okay? The contours should, I mean, we developed it here in class number 6, but actually the contours geometry, you can use as an input any type of geometry we have done till today, except the gradient building, okay? You can use the shear angle, you can use the shear angle, you can use the non-scale, the scale non-uniform, you can use the twist, okay, building, the one that you like, or only the rotation, the one that you like, okay? Or the source geometry. I have no preference with this, okay? In this case, I came here with I introduced the twist, okay, the twist version, but you can put anyone, okay? So I don't know, organize your code as you like. I have divided by classes. You don't have to. I recommend because maybe it's a easier way to follow it, and then you follow me also. But remember, with this part, I'm going to put it actually, even if we did it in class number 6, I am going to put it in class number 8, okay? And then we are going to work from here. All clear? Any question till here, guys? Because today we are going to continue with this. We are going to keep on working with this. Is that clear? Yep. Okay, good, good. By the way, sorry, because you should have received the grades of the, well, just the grade, the 0 plus or minus. I mean, if you submit, you don't have minus. Okay, at least, unless you submit you don't have minus unless you submit, I don't know, a picture in the beach or having holidays or something like this, okay? But if you submit something, you're not going to have minus in the course, okay? What I want to say is you should have received your grades for the intermediate submission. The problem is that I need the student list, and our team assistant has been sick the last 2 weeks, 3 weeks. We didn't expect this, to be honest. As soon as they send me this, I will place the grades and upload the grades into Ilias. Okay, so each one of you have individual access to your grade. Okay. So, guys, let's gonna start working from here. Today, by the way, you need to learn how to install a plugin. This for sure will be a little bit difficult, but actually, let's going to do it now because we will need this component that we have here. Okay. So, how to install a plugin in Grasshopper? Because your next step in your Grasshopper development is first you learn how to use Grasshopper. Okay. You learn about the trees, the list, how to handle geometry, how to handle data. Okay. And then the next step is okay, but how can I do all things that you are watching online, all this crazy stuff? Most of this is plugins. Okay. Plugins, you have it in one website that's called Food for Rhine. Okay, there are two ways to install a plugin in Grasshopper. Okay, I'm going to show you first the old school one. I'm old school guy. I'm sorry. But now I will show you also the new one. Okay, new. um, the plugin. This is for Rhino. This is a. Let me put it in English. This is a website from McNeil where people publish their plugins, and you have a lot of stuff here, webinars, and there's a lot of things going on here. And you can search for your plugin here. For example, the plugin that we are gonna download is Lunchbox. Let me 1 second. Instead of searching for Lunchbox, let me go. You have Rhino apps, Grasshopper apps. Now they call it apps. Okay. Grasshopper apps. Let's gonna click here in Grasshopper apps, and I think that we can sort them by number of downloads. Okay. Why this is in Spanish? Sort by downloads. Okay. The first plugin with more downloads is Lunchbox. Is the one we are going to use it. Okay. You have Ladybug. If you want to do some climate analysis, Kangaroo physics, this is super. Kangaroo, you don't need to download it right now because this comes by default in Grasshopper now. This is for structural simulations and things like this. Okay. Pufferfish is a multi-tool plugin. Elk, this is for urban development. Python, you want to code. There are a lot of bifocals. Is the one, by the way, that I use in classes. If you want to see this name here, this is bifocals. Okay. So you want to see things exactly like me, you can use bifocals and you have the same setup. But how to install bifocals? How to install anyone? So you click here in Lunchbox, for example, okay? On the Rhino package manager, be sure to keep Rhino up to date with the latest server release to ensure that, okay. The way to download this is you have to click here, but yeah, start session. I'm gonna start the session. Let me 1 second because I don't know you place here let me do it 1 second. I need to go. I don't know my password. It's here. Give me a moment. I need to put the password here. Put for Rhino. Okay. Okay. You put here the password. Not now. Don't know why this appear by default in Spanish always, to be honest. I want to hear in English, but it's impossible. Automatically change to Spanish. Maybe it detects that I'm from Spain. I don't know. Okay. Now I need to search again. Very Lunchbox. Okay. Lunchbox. And then,
Quick question. Do we also
yeah,
have to download the Lunchbox file?
sorry.
Do we also have to download the Lunchbox?
Yeah, you have to download it also, Maren. Yeah, because for today you need Lunchbox. Yeah. That's why I'm doing this with you step by step.
Okay, thank you.
You're welcome. So, guys, here, I think that the Lunchbox, guys, they have changed it. Okay. If you click here to install, it will go directly. It tells you if it can open Rhino 8. I don't want this. We are going to install Lunchbox in this way, but I want to show you also how to do the other one, because for sure there will be a lot of plugins that we are going to use that are not available in something that is called the package manager inside Rhino. Okay. So, for example, you have Rhino 7. That should be the case of some of you. Not all of you have Rhino 8, maybe. You have to click here in download. Okay. Well, this has an installation file. This is what I want. Sometimes you are gonna find multiple options. Okay. This one is with an installer, with basically a software that installs the plugin in your computer automatically. Good. But this also has a problem that you're going to find now. The Other way is that you have to download a zip file. You download the zip file in your computer. Let me show you. I'm going to download it here in my desktop. And I'm going here, right mouse button, WinRAR, extract files here. I'm going to extract the files here. Okay. And then I have here the files, Lunchbox. Okay. It comes with a lot of files in this case. This is kind of complex. Okay. The one that you care the most is this one and this one. You have to copy everything. You have to copy everything. Okay. Guys, sorry, there is here one problem that I need to fix. Can you do me a favor? Can you try to download one of these files, for example, not the Grasshopper for Rhino 4 and 5. Try to download, I don't know. Try to download another plugin. Let's see Pufferfish, because it's maybe another plugin that is very useful for you. Install, 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 download. Yeah, download Pufferfish. Let's go install also Pufferfish together, okay? Download this file, everyone. If you don't have an account in Rhino created, I come in 1 minute, okay? Give me just 1 second, sorry. Solve it. Sorry. So, have you downloaded the files? Okay. So to install a plugin, guys, let's going to continue. I have here pufferfish. Okay. I'm going to extract files. Good. What is the problem? Usually, doesn't matter if what you are doing is downloading a folder or, as the case of Launchbox, downloading the installer, the a plugin that install the thing. In both cases, the installer is just a software that is going to copy paste files in one folder. That's all. Nothing else is going to do. Okay. So the thing is, with pufferfish, for example, well, you have here components, workflow. This plugin is developed in multiple files. It's a bit weird, but it's how they did it. Well, what you have to do for any plugin is just file, special folders, in Grasshopper, component folder. Special folders, component folder. Okay? And you open this folder here. Okay, guys? Files, special folders, component folder. All of you are you here? Oops, sorry. All of you are you special folder, component folder. All of you in this folder with me? Yep. Yep. Can I continue with this? Did you find it? No? What happened here? Why one thumbs down? Who put the thumbs down? You don't find the folder?
No, not really. It's a little bit too fast for me right now, actually.
Okay, man, sorry. So open Grasshopper, okay?
Yes, file, special folders, and then
File, special folders, components folder.
so I downloaded it, but my libraries is empty, so I can
Yeah,
see.
okay. This is not a problem. If you this is empty, right?
Yes,
Okay, no problem. That's good because you don't have plugins.
I
That's
thought
the
I
only reason.
downloaded it because in Rhino in the package manager I can see them, but I can't see them in the Explorer.
I explain you why. Don't worry. This is the way I'm going to continue, Maren, and I will solve your question. Sorry. No. Yeah. You are not going to find this information anywhere on the internet. I don't know why. But Grasshopper and Rhino work like this. This is the place where we usually, and when I say we, are Rhino users from Rhino 4, Rhino 5, Rhino 6. I was started using Rhino in Rhino 4. We start plugins here in this folder. Okay? So whenever you download, guys, whenever you download a file from internet, for example, this Lunchbox, okay, that I have downloaded, or give me a second, I go to the desktop, or this pufferfish, if I want to install it, I just copy paste. I can copy paste the entire file here, pufferfish example 3.0. I can copy paste it in my libraries folder, in the special component folder of Grasshopper that we enter, no? And I Control C, Control V, paste it, install. Okay? The only problem that you're going to find, and please pay attention now, everyone, because I ensure that 50% of the class, if you do it like this, you're gonna find the problem. You're gonna have the problem. Is Windows and Mac by default GHA extension files, which are the extension GHA, things which is like a not a virus but a potential threat. Okay, that means that, for example, I am going to come here from here, I will try to copy my lunchbox. I'm gonna copy just this one, okay? Even if I need to copy everything, eh? If I were in Rhino 4, Rhino 5, I need to copy everything. You don't need it. But imagine that this is my plugin. Sometimes plugin come only in one file. This is the most common case, not this. This is not the common case, okay? And I go back here and I paste it. I think that I have finished and my plugin will be installed. What I need to do now is close Rhino, close Grasshopper, reopen it again, and then we have the plugin installed. The problem is, let me see if it happens now. Nice, it happens. You see this screen, right? I do right mouse button, properties in the file. Right mouse button, properties. And I open this window. Security. You see this thing here, right? This file came from another computer and might be blocked to help protect this computer. Okay? This file is blocked. If you want to use this file, you need to click unblock and then apply. Click OK. You need to restart Rhino, restart Grasshopper, and then you will have installed it. Okay? I'm going to delete it. This is, sorry, Leona? Okay.
So we're supposed to download Lunchbox now as well? Because
No. Wait a second. Lunchbox, they have changed it now. You don't need to download it. This, Leona, I have explained it because a lot of times you are going to find plugins in Grasshopper that you need to install it like I have done now. For example, if you want to install pufferfish, I think that there was no pufferfish. There was no discrete vectors. I don't know, the one that you like. Ah, yeah, there is an install. There was an install button. Okay, so whenever you see install, this means package manager. Whenever you see download, this means you have to download the file, like I have done it. Like I have done it here with my desktop, pufferfish. Okay, and you have to copy paste this thing in your computer. Okay, in your computer, where in the folder where I show you, file, special folder, component folder. This is the way in the case the plugin doesn't have package manager. Okay, sometimes they offer both also, like pufferfish. Okay, they offer both. They offer the package manager with the install version and the manual installation. Okay, exactly the same. Good. Option one, you don't need to use this one. Sorry for telling you this, but I want you to learn more things than only the one that are needed for this course. And this one, you are going to need in your life for sure. Okay? So you start applying here. Second option, new plugins. Plugins that have been developed in the last 2 years, or they have been updated in the last 2 years. You very likely, and I say which is not always the case, you will find something that is called package manager. You have here a command in Rhino that you write package manager, and you have here your package manager. Okay. There are two tabs here, online and install. Those are all the plugins which I have installed, for example. One of them is Lunchbox. Okay. Let's gonna click online and let's gonna search for Lunchbox. Click enter. Okay, this lunchbox that you have here is the same one, should be the same one as the one that the developer is offering in Food for Rhino lunchbox. Should be the same. Okay, if I click here, install, see the version 2025-550, 2025-550. They publish, they release 5 of May 2025. Okay. Then you click here, install. Okay, you click here on install, and then you have it installed. Okay. I have multiple. I have Caramba, Lunchbox, Openness, super useful plugin, Opossum, Webbird, robots to control robotic arms. Okay? Okay? Found it, guys? Now you need to do this one. This one, do it. Install the plugin like this. It's okay? Could you install the plugin? This will take some time. Every year it takes super long to install the plugin, but I want to do it with you. Thumbs up. Nice, nice. Okay. Good, everyone? Super easy. This is why they develop, very good. This is why they developed the package manager, because sometimes it was a bit tricky to install plugins in Grasshopper. Okay? Good. So, but now, okay, we have installed it, but do we have installed the plugin in Grasshopper? Actually, let's gonna search for it. I'm not quite sure. You should have here one Lunchbox tab. You see that I have here multiple tabs, Caramba, Millipede, I have another one here, robots, MetaHopper is called, human, I have a lot of plugins, no? I should have one that is called Lunchbox. I'm not quite sure if you have the tab there or not. Yeah? Okay, you have it. Nice. So then you have installed the plugin. But I remember who was asking me before, but Javier, I have here plugins installed, package manager. I have here plugins installed, but my folder file is file a special folder, component folder in Grasshopper is empty. How is this possible? Because Grasshopper uses two folders for plugin and not only one. The first one is the plugins which are installed manual. The second one are the plugins that come from the package manager. Okay, plugins that come from the package manager, I have no idea where they are. I have the folder here in my computer and should be placed here. The folder changed for everyone. You see the path. In my case is C, users, my user, app data, roaming, McNeil, Rhino, packages. This is the folder. I'm going to copy paste it in the chat. Okay. When you enter in this folder, you will see the different versions of Rhino. I have two versions of Rhino installed in my computer, Rhino 7 and Rhino 8. Don't know why. I should delete Rhino 7 one of these days, to be honest. If I click on Rhino 8, here I have my plugins. That comes from how it's called? From the package manager, okay? The structure is the same. If I can copy paste things here by myself, and then, yeah, it will work the same. I have two versions installed. The thing is, the manifest shows, this is a text file that shows the version that the program should run. Okay? Don't touch anything here, guys. Okay? Okay, clear enough? Plugins installed, check for everyone. Sorry, because for Mac users, I don't know where is this folder, to be honest. I don't know where is the folder. You also don't need to know it, to be honest, but I mean, I can search it for you. If somebody has interest or needs to know where is this folder, write me a message and I can search for the folder. Or for sure, there is in some forum or in the Grasshopper forum. By the way, there is a super cool and is really good Grasshopper McNeil forum. Here you can directly talk with the developers of the software, directly with people from McNeil. You log in and you ask questions, and you have a lot of. This has been developed for I don't know, a lot of years, 2014, something like this, 2012, this thing started. And it's really, really useful. I usually get answer with David Rutten, which is the developer, or the main developer of Grasshopper. So it's super. Okay, really amazing. And you receive answer, don't think that it's gonna take long. You receive answers in minutes. So it's like really useful. Good. So let's gonna come back. So now that you have downloaded the plugin, we are going to use the plugin only for the panels tab, okay? And we're going to divide our floor plan using different subdivisions algorithms. For example, we have diamond panels, hexagon cells, okay? We have quad panels. I don't remember how many did I use last time. Diamonds, hexagon, triangle panels, B, staggered quad panels. Let's gonna see staggered quad panels. What is this one? Sounds interesting. Staggered quad panels. Okay, better than quad panels, like this. Let's gonna use those three. Okay. Guys, in short terms, what we are going to do is we have our building, no? We have divided in different floor plans. Those are the floor plans of my building. Then we are going to divide those floor plans into different patterns, okay? Into different patterns. And those patterns, we will extrude them following the line of our building, okay? This is going to be the definition that we are going to do today. So the thing is, the first thing that we need to do is divide the surface. For example, I'm gonna use the diamond panels, okay? It's asking for three inputs, surface, U, and V. Surface is, of course, the surface. The problem is my building is like this. So the last part of the building, I don't want to count it as a floor plan because it's the roof, okay? So the first thing that we'll need to do is to remove this item, okay? How can I do this? So remember, there was one component that was called remove. No, it was called cool index. For example, we can use cool index, or I think that I used cool index I used last time. Okay. Remember our data structure, right mouse button, param viewer. Okay. I put a param viewer and I see my data structure are three branches, which are three buildings. And for each branch, I have a number of subdivisions of floor plans. Okay, depending the height, of course. So I am going to delete the last one. So for this, the cool index, the index, remember, is -1. -1 means the last one. Okay, I connect this one here and I put this one there. This one and that one. Okay, like this. Good, guys. Okay. So now I have deleted the last floor plan, as you can see. Okay. So now with this, I can enter here in the diamond panels. For example, I'm going to enter with my surface. Okay. And what is asking U and V for a number of subdivisions, no? Okay, so this is a number. Let's gonna place a number from 0 smaller than 20, for example. Okay. Let's gonna place an U and V parameter here. I don't know, let's gonna place 7 by 13, something like this. And here we go. Okay, as you can see, I'm dividing my building, every floor plan, with different subdivisions. It's working for all of you guys. Then comes this U value thing later. Okay? Yeah, Leona? Very good. Well, this is reduction strategies that we are going to apply now. Let me have a look for me to remember how did I did it last time. The vector for the extrusion and then extruded. This is a bit messy because of I have a problem with a plugin here. You can see. Okay. So now this comes from where? From the points. Okay, I have the points here of the areas. Okay. Good. So what we should do now, guys, with this is we are going to reduce it, okay? Because, I mean, otherwise, if I extrude it, the last point of this will be extrude, okay? What I'm going to extrude? These subdivisions that, by the way, by default, in this component, come in two parts. Geometry. Come in two parts. One of them are the interior diamonds. I am going to do another subdivision because this is a bit weird. Like this. I think that this is better for you to see. Okay. We have the interior diamonds and we have the triangles in the perimeter. Okay. By default, this thing comes like this. Okay. They have the important thing here is that they have the same data structure. Param viewer, sorry. Now we need to start using param viewer because our trees are getting more complex. Okay. They have the same data structure. I am going to simplify.
Sorry,
Yes.
how did you get the U and V division?
Sorry.
How did you get these two, the U division and V division before the diamond panels? Are these just number sliders?
It's just a number slider. It's just a number slider.
Ah, okay.
Okay. It's just a number. I just put here a number. Done. Okay. So I'm dividing my floor plan in the interior and the exterior. Okay. In this case. And by the way, guys, please simplify. Simplify. Right mouse button, the output here, simplify. Right mouse button, the output here, simplify. Okay. Let's see what happens now with my tree, guys. Can somebody tell me what has happened? Because take a look, the tree where we come from. We come from a tree. I'm going to simplify also this one, by the way. We come from a tree that is branch. Every branch is one building. I have simplified everything, okay? These two outputs and this cool index also, I have simplified the tree. I have one branch per building, and then I have a list, which every item on the list is the floor plan, okay? Good. Is clear this? Is clear this, guys? Yep. Okay. So then, after applying this component, I have this data structure. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, blah, 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 blah. And on every item, I have 12 panels. Sorry, I said. So then, in this data structure, the first index is my building. The second index is my floor plan, FP. Opa, sorry, FP, okay? My floor plan. I'm not very skillful with Zoom. And then 12 is the subdivisions in my floor plan. Okay? Good? You see? So I have 3 buildings where every building has different number of floor plans depending the height. And on every floor plan, I have the same amount of subdivisions. We will change this thing later, okay? To make it look a bit nicer. Okay, guys? Is that clear? What I need to do now? I need to do random, first of all, I am going to merge those structures, okay? Because I want to have it in the same list. So if I use merge here for this one and for this one, the output that I have from here is, instead of having 12, I have 24, okay, items per floor plan. 64 branches, 68 branches, you see, and a number of items per branch. Okay? Is that fine, guys? Is that clear for you? Yep. Okay. So here we have the subdivisions. Now, what we need to do with these subdivisions is just extrude. We are going to reduce them. We are going to remove some parts in them. And later, we are going to extrude them. Okay? So then, to reduce them, I am going to use something that is called random reduce. This component, random reduce. Whenever you see the word, how can I draw here? I want to draw. Can I draw? Guys, I'm sharing the screen. Guys, are you seeing my screen?
We can
Yes,
see it.
yes.
Yes? Okay. Because earlier I was not watching the... I can draw here. Okay. Yeah. Whenever you see random, the word random in a component, you need to think something that is called seed. Okay? I think that we talk about this. This seed input comes because this is not random. It's pseudo-random. It's not possible still to do a random whatever. Okay? So the random reduce, what it's asking is, okay, give me the list of elements. Doesn't matter what it is. Can be numbers, can be surfaces, can be whatever that you want to reduce. Okay, I give you the 3. Good. Now what I need is number of items to remove. Let's gonna put here just a number. Okay, let's going to copy paste one of the number sliders. Let's gonna put 15, for example. As we're going to continue, let's going to connect it in the R. And then we have also something that is called the random seed. Let's see what happens. Random seed is going to be the same for everyone. Number 1. Okay? So what we are doing now, let's gonna copy also this one. And let's going to provide here also a number. Instead of 1, let's gonna put a 7. Okay? What we are doing now is for every floor plan, okay, we are deleting 15 elements, or the number that you want, okay? The number of elements that you want. The thing is, for every floor plan, we are deleting the same amount of elements with the same random configuration. Okay, with the same random configuration. That's why you will tell me, Javi, but why I am deleting every floor plan the same? The same amount is obvious, but the same, let's say, location of elements in my floor plan. Why I'm deleting? Why I have here the corridor in my floor plan like this, and here also the same, and here also the same? because the random seed is the same for everyone. That's the reason. Okay? What we will need to provide also is a different number for every floor plan. And then the reduced configuration will be different. Okay, understood this part? Then, guys, the last step of the class will be, we need to extrude this. We need to extrude what? We need to extrude our reduced version, okay? But now we need a direction. The problem with the direction, you will say, okay, well, this is easy, no? Because I am doing this vertical. So then let's go to extrude it vertical. The distance between the floor plans and the distance between the floor plans, and then done, no? Easy. Well, no, because if you do this option, I am going to connect now this option here, the shear angle option, is not vertical anymore. Okay, is in this direction. Okay, so it's not vertical anymore. How to handle this? I think that the last time I got the vector from the, I think we can do it simpler this time. Let me see if it works, okay? Really here, this comes from the point, yeah, from these centers, okay. Good, good. So where come the vector? Let's gonna try to do it this way because it's easier. It comes from the center of each one of those surfaces. So I will need to do an area, or yeah, let me do an area here. Okay. So the vector to extrude this first set will be this one. The second will be this one. The third will be this one. The fourth will be this one. This one, this one, this one. So what I need to provide now, and this is a bit complicated, is a structure. I am going to simplify also the random reduce. As you can see, I am simplifying all the time because otherwise my tree gets more complex when it doesn't need to be so complex. What I need to provide is the same vectors, the same vector structure, data tree structure, to the extrude component. Okay? How am I going to do this? As I said, I'm going to find the center of each one of those areas and then find vectors individually. Okay? So I am going to put here the area. Let's gonna do one thing because I usually like to do it like this. This is my well, wait a second. I want to do it as clean as possible. How am I going to call this? This is, I'm gonna put a name here. It's going to be called right mouse button floor plans. Okay, press on the bucket. Then we are drawing the name, and I am going to copy paste it, connect it here, and bring it here. Okay, this is going to be my floor plans. I am going to right mouse button wire display hidden for this component, so I don't see the wire, and I connect this one here. Okay, it's the same. This component is this one, but I bring it here. I connect it just for organization purposes, okay, of my definition. Good, good. So then, guys, what do I have now out of the area component is, first of all, I should have a tree, I think, no? Good, amazing. I have a tree with 3 branches, 1 per building, same structure as here, okay? Now, what I need to do is, I need to create the vectors. How to do this? What I'm going to do is, I'm going to do a polyline. I am going to do a polyline that connects all the vertices. Okay? And then I want to divide this polyline in these steps. Okay, in these steps. So for this, there is one component called shutter. With shutter, I can use it, and then parameters t at least. But with shutter, I think that I use it with curve closest point. Yeah, I need to use with this. With shutter, I am dividing this curve. I can divide this curve in t. You remember t is parameters as least. Parameters to split at. Parameters of what? Parameters of the curve. So if your curve, imagine that goes from 0 to 1, what I need to do is find that this point is 0. I don't know, 12, 0 0.24, 0 point whatever, okay? And find these parameters and provide these parameters here to divide this curve in these parameters, okay? How to find this t parameter? Curve closest point, okay? I have here my curves. Sorry. I have here my curves and I have here my points, okay? And the t is a data tree with the parameters of my curve, okay? In this case, if I can reparameterize my curve here. If I reparameterize here, you will see that my parameters go from 0 to 1, all of them, okay? You see that they have changed, right? Before were meters, the meters of my curve, and now the parameters go from 0 to 1. I usually like to reparameterize. You can leave it without reparameterize, but for me, I usually understand things better that goes from 0 to 1, that if I don't know if this is doing it correctly, because sometimes I don't know the length of this curve, and I don't know if the end point is the correct one or not. Okay, just saying. So I prefer to have from 0 to 1, that I always know if the shutter process is going to be correct or not. So now what I need to do, guys, is just connect the polyline with this t. Okay? And here, what I have now is a I'm going to simplify also here. Is a tree with 8, 16, and 28 lines. Okay, line-like curve. So I have subdivided my polyline, my extrusion polyline, into different segments. Okay. What I'm going to do with these segments, I am going to extrude these pieces with these segments. I think that maybe we do it exactly like this. This is going to work, but wait a second. Let's gonna have a look. If I do like this, is working? No, it's not. Don't do it because we are doing it wrong, and I can tell you why. I don't know. I think that is correct. 8 pieces. How many pieces? Well, let's go to see. This is working, okay? But we need one thing else. I usually prefer to have everything clean as possible, because you may have problems if you don't do it like this. So guys, the first part of the definition is going to come, which is I come to the extrude with my parts or my floor plans on one part and with my vectors in the other. Can somebody see the problem? Can someone see the problem here? I have here a lot of branches, right? I here only have 3 branches. Okay? What do we have to do? I need to match both data structure. Whenever you go into one component with different types of data structures, very likely you will need to match them before. Okay? Okay, guys? What I want to do actually is that all the items in the branch 00, I want to extrude them with the item number 1 here in this branch. All the items of the branch 01 correspond to the item number, well, item numbers, they will be 0 with the item number 1, okay, of this list. So what I need to do here, in this case, in the shader, is increase 1 level the tree. Okay? Right mouse button, graft. Remember, graft is creating a tree or make it a bit more complex. Flatten is kill the tree. Okay? So then graft, and then take a look. I have 52 branches, 52 branches. Okay? 00, 01, but 00 only with one item. And this is correct because what I want is, as I said, these 8 items that I have here, this branch 00, I want to extrude all of them with one vector. Okay? Okay, guys? Understood? So then if I go here with my extrusion, now it's working. Before we were doing incorrectly. You see it was 1.5 seconds because I was doing a lot of duplicate geometry. Now, before, let's gonna see it before. Take a look what is happening here. I'm gonna remove the graft. 980 seconds. This has increased. Why? What is happening here, guys? What is happening is, I can tell you. This branch 00, it's very difficult to show it in geometry because geometrically is correct. I mean, the problem is that the branch 00, where it is, this one, well, I can do it with Grasshopper with the, is extruded with 8 vectors. Okay? With 8 vectors. The branch 01 is extruded in the branch 0 with another 8 vectors. You know? I cannot show it geometrically, the problem in geometry, but if I bake this into Rhino, you don't have to do it. This is just for me to show you why it's not working. Yes. Let me show you. Here you see how many duplicated poly surface do I have? I have a lot, you know, because all of this is extruded with these 8 vectors. Okay, remember guys, longest list. Understood? And if I do the graft, and if I bake it now, there will be no repetitions anywhere, you know? Okay, because I am matching geometry with geometry and data, of course, the geometry and the vectors. Okay, guys, did you understood this part? Now you can change as you like this geometry. You can do it with the shear angle. You can do it. I'm gonna test also with the, for example, this one, no, the non-scalar scale non-uniform. Sorry. The scale non-uniform version, okay? I connect here the scale non-uniform, the script word scan, divide my floor plan, random reduce the floor plan, and then extrude the version, extrude this thing. Okay. Again, the data structure is the same, 0, 0, 0, 0. Perfect. Param viewer. Let me have a look with the param viewer. If everything is working. It's working. And this is working. This good. 60 branches, 60 branches. Same data structure. Here I have whatever number of subdivisions, and here I have always one vector. Good. Okay. You can change whatever geometry you want. You can change also the subdivision algorithm. Instead of diamonds, we can apply for hexagons, for example, or for triangles. Let's gonna see the hexagons. Let's gonna do hexagons, for example. Next day, I will bring also some results from previous year, and you can see how, I mean, the cool design that the previous student they did with this, okay? So here's the same. I come here, I put the surface here, and then I put here two numbers, U and B, okay? And then I divide this. The only difference, guys, is that in this case, in diamond and triangles, I already have the surfaces. And in the case of the hexagons, I am going to have cells, okay, which are not panels, is cells, okay, which are curves, basically. Polyline curve, okay? This is very easy to fix. Just use surface component, put it here, done, okay? You have already your hexagons. And now the thing is that you need to change this merge, instead of from here, comes from, to change, I mean, the random reduce, instead of coming from here, comes from here, okay? And then at the end, the process is exactly the same. Hey, but wait a second. Okay, guys. Understood this part? But we have a problem. Can somebody tell me the problem? With shutter, we cannot go directly here. We need to do something else. I'm sorry for this. Can somebody guess the problem? This is our building. What is this? We have like a hole here, no? We need to fix it. This was more visible in this option than in the previous one. Can you see the problem? We need to, it's not possible only to go here with the curve. Curve is not working by itself. Okay, we need to create the vector. Let's go to create the vector, okay? We need to use amplitude vector, okay? We are going to create the vector with the amplitude command. Then we need to get the vector, construct vector, no, is vector, okay? Then I have here the vector, okay? And I need here to have my length, the length of my curve, okay? And then with amplitude, this is 1. I am going to, this is my vector. I'm going to unitize my vector. If I connect here the amplitude, I have the correct vector version, and then I connect it here, and this is working. What I have done, guys, instead of putting the curve directly here, that the length is not represented correctly, what I'm doing is I am creating a new vector, just saying, okay, what is the direction of the vector? This one. But I want to unitize the vector for this vector being 1. Then what I want to do is calculate the length of the curve, okay? That the length is a number, okay? 2.2 in this case, and another one will be, all of them are 2.2. Okay, good. And then with this length, I use the amplitude to create a new vector with this length and this direction that is unitized. And then this will be for sure correct. Solve it. Here with me. It's clear, guys. I'm explaining things correctly. Do you understand? This is a bit difficult, to be honest. This is the hardest part of the year. If you are able to pass this, the rest is easier. Believe me. This is the tough part of the year today. Okay? Here, the vector. Imagine this without recording. I mean, first year were tough. Okay, and here we have the floor plans. All clear. I'm going to come back to my shear angle option. I prefer it because it's more difficult. If I am able to do the difficult part, I will be able to do anyone. You see, it's working my building. Okay? I don't know, Nelly, Julia, somebody, tell me something. I want to know. But thumbs up because it's thumbs up or thumbs up because I asked you?
No, for me it's working. It's all right.
For you, it's working. Super. Super. The rest also, no? I hope so. Please, if not, guys, just tell me something. Otherwise, it's very boring also being here talking alone for an hour and a half, 2 hours. We are going to extend today a little bit the class, okay? Just a little bit because we need to finish this, okay? And I want that everybody understand this. So today is difficult. Okay, so guys, this is the general definition we have for today. Okay, but we need to improve certain things. This is boring. Okay, because I am just always deleting the same number of geometries. Always the same. No? Good. How can I delete different how can I delete different elements per floor plan? Can somebody guess? How can I do this?
Maybe if we use an attractor point to work with this.
Nelly, maybe we use an attractor. Last year, I did it. You know, Nelly, at the end, well, we need to, by the way, thank you for following with me. Last year, what I did was a random number. Put here whatever number. And then, if you put here whatever number, you will have different reducing parameters, okay? But what you said today maybe makes more sense because it's not about an attractor point. Now what we need is provide here different numbers. But what do we have here? We have cells, right? So those cells, each one of them, we can put an attractor point, for example, Nelly, very good, and calculate the distance between this attractor point and the center of each one of them. This will give us a number. And this number, we can provide it to the source. But the problem is, the thing is, I want, let me check because this is tricky. I want to have one number per floor plan. Okay? I want to have one number per floor plan. So I don't want to have nearly 200 numbers, you know? I want to have just one. I can do this here, for example, and calculate, and then I have one number per floor plan. I like your idea, Nelly. Let's go to do it, okay? If it doesn't work, it's your fault. Okay? Let's go to calculate the area of each one of the floor plans. Okay? Then we have a point. Okay? With this point, I'm going to put an attractor point. I just want to do it like this, Nelly, because it's easier than mine. Set one point. I'm going to put the point, whatever, here. Okay? And I'm going to calculate the distance between those 2 points, between this one and this one. Okay? Then here, I will have different numbers. Good. Then, Nelly, here comes the question. Random reduce, I mean, I'm going to connect a param viewer here in the surface. Take a look at the structure. Building 1, building 2, building 3, building 1, 0, 1, 2, sorry. And then floor plan 16, okay? And here what I have, Nelly, is 0, 1, 2. How can I match the data structure, Nelly?
Didn't we use the graph?
Super, 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 Nelly, plus, 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 plus. Here we go, okay? Super. 52 branches, exactly the same data structure. And then I have what I want, a different number per floor plan, okay? A different number, which means that I will have a different random reduce per floor plan. Super. If now I extrude this is starting to look way better. Nelly, very good. You simplified the definition this year. Last year it was like this. Well, it was also not very, it was like this. It was like this. For every floor plan, I did this thing, okay? Generate a different random sheet. It was kind of similar, but I think that yours is better. I like more yours. So then changing here things is a matter of an attractor point. And then if you move the attractor point, check it. If I move the attractor point, I am modifying how these floor plans are being modified. Okay?
I'm
Good,
sorry
Nelly?
for the question.
Yeah, Chiara.
The area item, with which one did you connect it? Where
This
is
one
it? Yes, exactly.
with important point, Chiara. With this one, with the cool index, where I delete one of the surfaces. Okay, with the entire floor plan. Okay, with the entire floor plan. Don't connect it with the cells or with the diamonds. Don't connect it from these surfaces because it will give you a lot of numbers, and you only want one number per floor plan. You only want this thing that I have here. Okay. Good, guys. Okay. Um, Okay. Okay, this will come later. But guys, one thing. I have adjusted the other time depending the set coordinate, the number. So okay, yeah. That's good. Okay. This is okay. Random reduce. So everyone here with me? Is clear? This part, Nelly, super. For the rest also, I know that Nelly is following the class. The rest, okay, Nina, and the first, super, super. Sorry guys, because we are so many that I have to be changing the screen to see all the thumbs up. Good, good. Let's going to improve this. Hey, what is going on here? Why this thing is not working? Because I have to connect it. I have deleted something here, I think. 1 second. I think that did I delete something here? Yeah. I think that I delete floor plans. I delete this one. Don't know why, sorry. But I have like half of the definition not working because of this. Yep. Where display hidden. So, guys, this is working, but we can do it better. We can do it better. This looks super cool. By the way, if I make it, let me have a look. This looks pretty cool, but let's go to improve it. One way to improve it will be to increase the density. I mean that this building is more dense in the base, less dense in the top. Okay? How can we do this? Because that would be cool, no? To start to see when you see those type of buildings that they are like doing like this how is it called? Pixels, you know? We will do one of them here, but after Christmas. So how to do this? The way to do this is when we are doing this density depends on 2 factors. The first one is the number of panels, okay? And the second one is the reduce, the number that we are deleting. At this point, we are deleting the same panels every floor plan, and we are creating the same amount of panels every floor plan. This we are going to modify it, okay? Now pay attention because this is a bit difficult. I prefer to do this in this order for you to understand the whole definition, and then we start adding complexity, you know, but at the end is what we are going to add here are numbers, but numbers that are going to be tweaked. Okay, what we are going to do, guys, is depending on the height of these floor plans, the number that I'm going to provide to the U and V is going to be depending this height, instead of providing just one number with a number slider, okay? So first thing first, what I need to do is find the height of these, find the height of these floor plans. Area, component, and then I have here the points, okay? And the set coordinate is the height. It's always the same, right? It's like 22. Well, depends on the, let's gonna get the set coordinate. So deconstruct point. Okay, I deconstruct the point. And here I have it. Okay. Here we have the heights. Super easy, no? Here I have the heights of my building. Good. What I need to do now is a way where I remap those heights into 2 values, into a domain. Okay, where I say, where is the minimum? Where is the maximum? Okay. So what I need to do here is remap numbers. I need to remap. What numbers do I want to remap? These ones, right? But here comes a problem. Here comes a problem. The next step in the remap. I am remapping a tree. Okay? And I don't want to do this. I don't want to remap. I mean, if I remap the entire tree, guys, all the buildings, the subdivisions will be the same. This building, the subdivisions are going from, imagine, 2 to 20, if this is my bounds in the remap, okay? But this one is going to be the same, 2 to 20 and 2 to 20, or the other way around. 20, the maximum, to 2, 20 to 2, 20 to 2, and I don't want this. What I want is, depending the height or depending the area, we can do this also. I did it this time depending the height. We could do it also depending the area, but I want that 20 to 2 is applied in all cases. Okay, not per building. Okay, so there will be, here we will have the less density, but here the 4 floor plans will be similar, the density for each one of them. Okay, so here I need to flatten. I want to kill my tree at this point. Okay, so here I have my list. Now I don't have a tree. Okay, now I don't have a tree. Okay, what is, I am going to use the bounds component now, because what is the minimum and what is the maximum? The minimum is 0. All the 3 buildings share the 0, but only one has the highest, and is 59. And I want that the minimum, my minimum is here, not everywhere, you know, because otherwise will be very repetitive again. You know, having the 3 buildings, having the same gradient, and this gradient will be, I mean, you will not be able to control it because it's going to be too much. The gradient is going to be done in 1, 2, 3, 4, 5, 6, 7, 8 steps, you know, and this one will be done in 20, you know. So here the bounds are 0 to 59.4. Construct domain. I construct my domain and I remap the numbers. Okay. What is going to be my domain? 0 is smaller than, I don't know, let's gonna put 30, but take care with this. Okay, don't increase it a lot. The thing is, what is the 30? What is the 0? In this time, it's inverted. For example, let's gonna put 12 is here, and 3 is here. So it's going to be 12 to 3, not 3 to 12. Okay, because I want to go from more dense to less dense. Okay, let's do like this. This is going to be my target domain. Okay, what is my source domain? My source domain is this one, because it's the domain where the values come from, and the values are the set coordinates. Okay, so here what I have now is the list of numbers, as you can see, where I have remapped the values, depending the set coordinate. The minimum one is 12, and then it will be increasing. Now all the buildings are together. Okay, now for example, number 23 is 33. Number 23 now is 7. Okay, that will be for sure a smaller one somewhere, but okay. Good, so I have remapped the numbers like this, like what I wanted. And here comes the thing. Can I go directly with those numbers here? Nelly, come on, today you are on fire. Can I go with my numbers here?
No, you cannot, because you try to merge a tree with a list.
Yep. Wow. So good, Nelly. Did you know Grasshopper before or not?
No, I'm just learning with you.
Super. Very good. Very, very good. By the way, guys, I will give you the classes that I give you are very basic, you know? Very basic. It's not basic, but I mean, we don't have a lot of time. I will give you resources for these holidays if you want to learn more about it. You can expand your knowledge. I will give you some books, some websites also, free and paid versions, depending on what you want. And then you can expand your knowledge in Grasshopper and be more proficient in the tool. Okay. With Rhino also, it's not only about Grasshopper. So as Nelly said, the problem is that I cannot put it because the data structure is different. It's going to be a mess if I put this thing in. Actually, my computer will crash. I'm going to save the Grasshopper, by the way. What I have to do, match this data structure with this one. But now we have a problem. It's not only, if I graph this, it's not working. Of course it's not going to work because this is not about grafting. Is I have to create a tree where in the first branch I have 8 items, in the second branch 16, and the third one 28. The way to do this, guys, is I need to calculate the list length of each one of those items. I will have, I will have now 8, 16, 28. Okay? And now what I have to do is this list, param viewer, sorry. And now what I have to do is this list with 52 items, I need to divide it in 8, later in 16, and the rest in 28. Divide, I think that it was called divide list or something like this. I don't remember. Partition list. Yes. The component is called partition list. Okay? For example, if you learn Grasshopper by yourself, there are a lot of things to do this. I think that this is the easiest, but you can partition lists. There is also a split list into indexes. You can also do it with this. I don't know. For me, the easiest one is partition list, but there are a lot of components here that you can learn by yourself. Okay, also if you work a bit on it, and for sure there are better ways to do this. My way is just one, guys, and I'm not as the best programmer in the world, of course not. So I remap this one, okay, with these sizes. Let's going to check because I don't know if the sizes I need to provide it as a list or as a tree. I don't remember. What do I have here? Param viewer. Let's going to see. Okay, it's not working. It doesn't work with a tree. Okay, because if I have here 8, what this thing is doing is getting these 52 items, Wait a second. This component is not working with a list because this is getting the 52 items and dividing the 52 completely first in 8 parts. 8, 8, 8, 8, 8, 8. Then when it finishes, 4, because it's the rest for finishing the list. Then 16. This is the 8. This is the 16. This is 8, 16. Then 16, 16, 16. Then we go with the last one, that is 28. Then 28, and the last one, 24. This is not the way. Okay, I want this to work. I have to do is flatten. If I flatten here, I have then a list, okay, with 3 numbers. So then if we are working in a list structure, I'm going to use now panels. What the partition list is doing is, okay, this list that I have here, I am going to divide it the first 8 numbers. Okay, that the first 8 numbers will be the first 8. I have no idea. Okay, then I am divided the list into the 16, the next 16, and then 28. Okay, and then I have at the end a data structure that matches my data structure exactly like this. So I can now place this in the U and V, and this will work. Okay, this will work because this has the same data structure. One thing, I usually copy paste this because this is for U values. Okay, and then you can copy paste everything and say that this is going to be for V values. Okay, and I change a bit maybe the thing here. I make it more dense or less or as you like. In this case, it's going to be less. I don't want to have always, of course, it has to be more than 2, at least 2, I think. Less than 2, I think that you may have an error. Okay, so then this is going to be my U. I'm going to stop this. This is going to be my U, and this is going to be my V. Let's go to see the definition works because it's the first time I do the definition like this, like not doing, from the beginning to the end because it was too complex and I want you to understand what you are doing. So here we go. At the top, we have very few items. At the bottom, we have a lot of items. That looks nice. Then I am doing the random reduce. Okay. 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 With these distances. Okay. The thing is I am reducing too much at certain point. Okay. If I reduce 16 items, for example, or 4 items, the problem is at the top I almost have no items. So I need to remove 4. Okay. And then I extrude it. Let me bake it and let's go to see how it looks. Okay, because sometimes in Grasshopper it's a bit difficult to see the geometry sometimes. Okay. Yeah. This is like this. It's good. What problem are we having, guys? For example, this one is dense here. What I will say, now this is starting to look better. I have some terraces here. I mean, my building is like this is going to fall. No, I will need to reduce a bit the geometry, but you know that this can be done later. This doesn't matter. We are doing algorithms. I have here a nice terrace. The problem that we are facing, guys, is the next one. The random reduce, then this is a number. The seed is working. Seed is working perfectly. We are creating this complexity that we are looking for. But the problem that we are facing is that this random reduce 4 at the top seems okay because I don't have a lot of pieces at the top. But at the bottom, is nothing. At the bottom is nothing. What do we have to do now? What I will suggest. Let's going to put here a number that we reduce the number of items per floor plan depending the number of items that is placed in this specific floor plan. Okay, so for example, basically talking. In the top, we will have less, the number will be smaller, and in the bottom, the number of course will be bigger. Okay, but always smaller than the number of total items that we have. So I don't find this problem that I have here. I'm going to delete more. If I put, for example, here 9, my building is disappearing completely. So this floor plan has no geometry from here. You see, my building should be finishing somewhere around here, but it's not because I'm deleting more elements that the subdivision in the floor plan has. Okay? So let's going to do this. The approach is very, 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 very simple. It's very, not simple, sorry, but similar as we did before. What do I have here? Param viewer. Okay? I have here param viewer. Here's the number of subdivisions per floor plan. I am going to, by the way, simplify. I always want to simplify things. I don't like, amazing. Building 1, layer 1. Building 1, layer 2. Building 1, layer 3. This is perfect. As you can see, I have different elements depending the floor plan. In the base, I have more. In the top, I have less. That happens, for example, you can see it clearly in building number 2. 59 in the floor plan. And then I go to the top and I have 6. Okay? Good. What I'm going to do here is that the reduction, we are going to do independent of this number. So for this exactly the same as before, I need to do a list length. Okay. So here I have the number of items that I have per floor plan. I have 59, 30, whatever number I have per floor plan in every building. Okay. What I need to do now, guys, is The random reduce has to be, let's going to think together again, has to be one number per floor plan that indicates how is the reduction that we want. So at the end, the structure is exactly the same as what we are providing here. Exactly the same as this, 52 branches. Should be something like this. It should be a number, and this number is going to be depending on this. We can do this very simple. For example, we can multiply. We can do a multiplication of this number by a factor that goes from 0.00 smaller than 1. So I can reduce on every floor plan 30, 60, 70%. Okay? If I do like this, I am done. You see? Let's going to connect this one here. Let's see how it looks. Now it's time to see it visually. Okay? Now we are reducing different amount per floor plan. You see? So 30% in the ground floor is, I don't know how many items, will be like 18, but 30% in the top floor is like, well, in this case, it's not a big difference because it's kind of similar, but in the other one, in the number 2, is 18th or 2. Okay? Can do it like this. I think. Let's see how it looks. Let's gonna put 39%, and let's see how it looks. Also, if you move the attractor point, remember that you are going to delete different parts. Okay, so now every floor plan is deleted in a different way. Okay, so let's see how it looks. Let's going to bake it. I'm going, by the way, I want to tilt a bit. This building is too much. One recommendation, guys. When you tilt the buildings, for example, now I want to tilt this geometry, no? So I'm gonna come here and change it. Don't change it here because it's going to freeze your computer very likely here. Okay? So my recommendation is, now you need to learn this. Select the input geometry and then right mouse button, enable, and you have disabled this component. Your definition will stop working. Okay? This part that goes from here to the right is going to stop working, but the shear angle is working. So I can now modify, for example, my attractor point a bit. Opa. I'm going to make it, I want to have this one, which is the biggest one, and then how did we change this? I had to change also a bit the values here, which are not so big. Okay, something like this. Let's gonna keep it like this, okay? A bit more relaxed, the geometry. Then click here, enable again, then this will recompute all the steps, and this is working again. Okay, let's gonna see how it looks. Right mouse button, bake. I'm going to group it. Yes, please. Bake it here, and then let's see. Okay, so this is with, I mean, this is start to look nice, to be honest. We have a lot of different situations on every floor plan. Okay. Let me see, because I don't want to put a lot of complexity here. I think that last year it was a bit more difficult. We reduced 2 times also here. The minimum number of panels. Okay. Depending the list length. We can use also this one. We are going to use it. Let's going to use this one, and then later we see if we need it. Okay, guys. The second reduction strategy. We have reduced 1 time only this geometry. Okay, I'm going to delete it. This is starting to look nice, but I want to implement another change, which is I want to delete this part. Instead of only reducing by a random factor per floor plan, we are going to also add a reduction with an attractor point. Okay, so I can create, for example, here a hole in my building. Can somebody guess how to do this? This is super simple. Can somebody guess? Nelly, you are on fire today. If you answer this one correct, you have a plus in the second submission. How can I do this? Reducing with an attractor point. Somebody? Somebody guess? It's very simple also, guys. No? No guess? We're almost finishing, eh? We're almost finishing now. No guess here? You can play also with this. So the guess will be, I have an attractor point. So 1 point. I have the center of the pieces. I have the center, okay? So I can calculate the distance between my attractor point and each one of those centers, okay? And then say, if the distance is smaller or bigger, as you like, smaller or bigger, smaller. If this distance is smaller than, I don't know, let's gonna put here a number, 0.00 smaller than 50 meters, for example. And then we have an attractor point that we can modify with a slider. I want to have a Boolean here, no? I have Booleans. The Boolean structure here has the same structure as this one. So I can dispatch literally or cool index or cool pattern, for example. You can cool the pattern also if you want. Yeah, I'm going to cool this pattern, this list, with this pattern. Okay, the distance is smaller. What is my attractor point? My attractor point is here. If I go up with my attractor point, okay, I'm having this amount of items, no, that are entering now in my something like this. Have this amount of items which are entering. It's a bit difficult because the buildings are a bit way. Let's gonna put them together. Okay. Oopa. Now they are classing. Maybe here. Yep. If this is like, yeah, something like this, no? That would be, for example, a cool one. So I can, instead of cooling this pattern, I can right mouse button here and say invert the pattern. So I am getting pieces, I'm getting the opposite, you know? Instead of getting what I'm removing, I am getting the opposite, you know? And then it's a matter of just change this one with this one, you know? So I am getting like removing pieces from here. If, yeah, you have to take care of this. I did also this extrusion. We can do also one thing to simplify things, which is the B-rep join on the merge faces. Yeah. if you want, guys, to make things easier also for your laptop, because when you bake it, you're baking here a lot of geometry, okay? And then if you put this in our, this is what I'm doing now, no? If you put this in our, is here, black border will be something like this, which has a lot of pieces. Maybe this is not what you are looking for. Maybe it's better. Let's gonna see how it what it looks better, okay? And we decide the one that you prefer. We can do also something like this, which is from here, do a B-rep join, and then merge faces. And then merge those faces. What is the difference? That now your floor plan, instead of being like divided, is a complete joined piece. Okay, you only have one piece here, okay? One or multiple, but I mean, take a look from 1, 2, 3, 4 faces to, I don't know, a lot of them, okay? And then extrude this one. Situation is the same or seems very similar, but your computer will take less than half to build this, okay? Than in the previous version. I can bake it. And you see that there is no difference. It looks the same. We can use this one, okay? I suggest to use this option, okay? This was the second reduction strategy, okay? This was second reduction strategy with an attractor point, okay? And here, I'm going to delete those two, was the random reduce. And this was for joining the faces. Sorry for today because I know that I'm making it a bit longer, but just a bit. Okay, I promise I finish very, very soon. Joining faces. And here I have the first reduction. Okay. For the first reduction, I think that this looks nice. For the first reduction, I think this looks nice. Anyone with problems or all clear? It's clear, guys? Please interrupt me if there is any question.
Sorry,
Okay?
may I ask where did you connect this floor plan surface with
This
which one?
this
Yeah,
TNG,
I mean
this
the
is
component. Yeah, the floor plan surface, the component. Where did you connect it? I mean you hide the line down. Yeah,
this
this
one.
this one. Oh,
Okay,
yeah.
okay.
Where did you connect it with?
Yeah. This comes
Okay.
from here, from the team tree, from the general floor plans, okay? From all
Okay,
levels.
get it.
Okay.
Thank you.
You're welcome. 1 second. I have the polygon here, data description. Use. I think, guys, that with this looks cool enough. You have to take care, okay? Because if you reduce, take a look. If you reduce, for example, one floor plan, now you see that takes some time, to load the things. If you reduce one of these floor plans completely, for example, I mean, doing this is not possible, of course. This part of the building is flying in the air. Your definition will work still, but I'm not sure if we are going to have repeated geometry. Cell duplicate. Oh no, we don't have duplicated geometry. Okay, there is no duplications. Okay, that's good. It's still working, okay, but take care because, I mean, this is not possible, okay? So you have to adjust your filter to be able to match the correct division. I have used hexagons, but you can use also diamond panels. Let's going to leave it like this, the multiplication, okay? I don't want to use, again, I think that this is enough. Let me delete, I'm going to delete this thing. We are almost finished. Let me, surfaces, polysurfaces. Yep. Okay, and this is, now the only thing that you need to do is playing with the amount of subdivision that you are doing, playing with the reductions, with the attractor point. You can play also with how the geometry is tilting. You can play with the deformation. You can play with the rotation. Okay, so next day I will bring the submissions of the previous year that they got one or yeah, there were some ones there. Yeah. So now it's time for you to start playing with your definition. Okay, playing with your definition and see how it gets adapted. Also, it's good because help you to test the definition is working. For sure, there will be some cases that it's not working or you put something wrong. Contact me, contact your hibis, and then we can start see what is going on there. Okay. You have also the videos. Watch the videos before contacting. Okay. So then we ensure that you have followed all the steps. And now you can put also here more panels. Let's go into, I don't know. There is also one that is called random quad panels. Well, random, no. I want the staggered panels, staggered quad panels. You can use also this one. Let's go to see how it looks. Let's going to change everything now. So for these guys, when you are going to, well, I can do it directly like this. I can connect here the surface. I can connect here the U, and this is going to be my V, okay? And I have here my panels, okay? Let's go to see how it changes. So now, from this surface, I'm going to change it to this one. If I have connected this one to multiple ones, if you press Control Shift, suddenly when you come here with the mouse, you see that there is like an arrow that is turning, no? You can click with your mouse then, and then release here, and then you have changed your pattern. Let's see how it looks now. Well, it's a bit different. I am going to reduce a bit this number, or where is my point? My point is here. It's also cool to have this attractor point at the top. As you can see, it's going really, really, really slow. I am going to, also another option, guys, is right mouse button, lock solver. You can lock the solver. You put here like a locker. Is lock my definition. So now I can move my attractor point, for example, to the top. And takes also a lot to load. Well, I can put it here. And then right mouse button, lock solver again, press it. And then you see we have reduced it like this. Let's see how it looks. Let me move a bit the attractor point here. A bit more to the center. It's a bit uncomfortable to be working in one screen only. Yep. Okay, let me see if I move it there a bit more. Okay, that looks better. That looks better. Let's see, you can put it also at the top, for example, and you have multiple delete positions. If you want, you can put another attractor point here and delete with two attractor points if you want. You just need to copy this thing. For example, let me see how it looks. Let's go to bake it. bake, buildings. Yes, please. I want to group it. Let's going to see how it looks with the shaded. Yeah, that's right, no? We have multiple situations here, like some buildings going out, some houses going out, some going in. The elevator could be like this. I mean, it's going to be very difficult to put here an elevator, but yeah, I mean, that would be one idea, for example, okay, of urban development of 3 towers. Okay, a small one. Oh, a really cool pattern. You see? Okay, so now it's a matter of being playing. Also, play here with the attractor point, and you can set multiple, different situations in the floor plan. Okay, but I think that at the end, the most important thing is that also have a little bit of fun with this, Put different, the one that you like, I don't know, you can use triangles also. Those are all triangles. I remember that there was one student that used triangles panels. B is called. I was, she did a really cool job with this. Let's gonna try to connect it here. It was the surface, UV panels, and then instead of doing it with this, I'm going to do it with this. Control Shift, change it, and now I see how it works. It's change a bit the feeling, Change a bit this feeling, you see? She did a super cool model with this. We were asking for a model a couple of years ago. Change a bit the feeling. But you can also play, if you reduce more here, it also gives you this corner, this type of shape, It's really cool, I think. Now it's time for you guys to work a bit and to explore a bit your definition and try to make it work and fight a bit against Grasshopper and struggle with lists and panels and all this stuff. We are done. Okay? Any questions still here? No questions. All clear. How to install the plugin, how to do the definition. Today, sorry, I know that it was a bit long, but I think that one day was needed. Also, you have now Christmas to rest. Okay, let me stop sharing now. Yeah, good. So we meet each other, guys. We meet each other on the let me check. I think that back Christmas is next class. We have it on the 9th of January. We are back again here, okay? Same hour, same place. And yeah, we will continue doing some Grasshopper definitions. After this class, after next one, we will start with the AI content. I'm not trying different AI engines to see which one is better this year. This change super fast from year to year. So well, thank you for being here. Enjoy Christmas. And yeah, if somebody has any question, let me know and we can have a look. Otherwise, see you next year. Enjoy Christmas, and I wish you very good year next year. Okay. Thank you for the Christmas tree, Julian. Okay. Thank you guys. Thank you for clapping. So enjoy holidays. Rest also a bit. Resting is important something. It is important also sometimes. See you next year. I hope that you like it. And if there is any question this holidays with Grasshopper, let me know. I'm here to attend. Okay. Thank you. Thank you very much.
Thank you and Merry Christmas.